To be a successful Java programmer, I think you need an understanding of three main areas, I guess I would say. First of which is your basic Java syntax. How do I make a class? How do I write an if statement? How do I write a loop? How do I define a function? And so on. So you need to know that basic syntax, Second is you need to know object-oriented concepts and design. This is a little more abstract, right? You can look up how to write an if statement. You can look up how to write a loop and so on. But the OO concepts, although you can get some information for you, there's not necessarily going to be a guide that will tell you exactly how to do something. Some of it you have to make some judgment and figure out for yourself. Now, we've sort of touched on this area through this class because we talked about classes and we talked about instance variables and encapsulation and data hiding and all that. So we hit on some of the main OO concepts. But really, this section of the class is where we're going to sort of switch into high gear and talk about OO concepts and design to a much greater degree. And the last concept is a Java API. In other words, the stuff that's already built into Java that you can do. For example, the array list. We looked at Java documentation, and you need to become sort of adept at reading that and finding the things that you want to do. Because nothing is worse than reinventing the wheel, as they say. DRY, do not repeat yourself, is sort of the mantra here. So if there's something built in that already does that, it's a tremendous waste of time for you to recreate that. So to know what's in the Java API, and more importantly maybe than even knowing what's in it, because you might not be able to know everything, but being able to find stuff that's in the Java API is important. Now, for today's class, I almost wish that we met on Tuesdays and Thursdays, because today's lecture would be perfect for tomorrow. All right, because today's lecture is going to be about relationships. All right, and that would just go so good on Valentine's Day, right? But alas, we're the day before, so consider this a Valentine's Day Eve lecture. And we're going to talk about the kinds of relationships that classes can have with each other. And we've sort of alluded to this, and we've touched on it and gone on, but we're going to go in a lot more detail in today's class and actually start implementing some of these things. There's several ways that objects can be related, but the main sort of dichotomy, the main split, is between objects that have an is-a relationship and objects that have a has-a relationship. That's really the main split. Now, the classes that we've considered thus far in the course have all had has-a relationships. All right? A project has a set of consultants that work on it. A project has a customer. A trip has lodging associated with it. A trip has an automobile associated with it, and so on. For none of those classes can we describe the relationship as an is-a relationship, right? A trip is not an automobile. I can't say a trip is an automobile, and I can't say an automobile is a trip. I can't say that a consultant is a project or a project is a consultant, all right? So on very broad terms, everything that we've looked at so far are examples of has-a relationships. Now determining which one of these two is probably the most important thing. You can further refine has-a relationships even more. We talked about collaboration and composition, for example. You could, for example, if you were implementing an automobile class is comprised of a set of components, right? A transmission and and steering and all that. That might be a case of composition where these things go together to make that. You could say, for example, that a class is composed of students and a teacher and a topic and so on. It's not necessarily important to say, is it an example of composition or just collaboration, though. You could just as well say, well, the list of students are collaborators in a class. All right? So I don't want to necessarily split hairs between, is it composition or collaboration? Both of those are has-a relationships. All right? The real big thing that we want to make sure we are able to distinguish between are examples of an is-a relationship and a has-a relationship. Is-a relationships are what you would call a form of specialization. That's another word for an is-a relationship. So, for example, if we have an automobile class, an electric car is simply a specialized version of an automobile. Another way to say it in the simplistic is-a terms that we said is an electric car is a car. An electric car is an automobile. A hybrid is an automobile. All right? A motorcycle, however, is not an automobile. All right? Nor is an automobile a motorcycle. You want to make sure that you get the is-a relationship going in the right direction, right? I can't say that an automobile is a hybrid, right? Because there are automobiles that are not hybrids. I can't say that an automobile is an electric car because not all cars are electric cars. I can say an electric car is an automobile, though, because all electric cars are also automobiles. All right? So that's an example of an is-a relationship. And, as I said, the term specialization relates to the fact that an electric car is really a specialized case of a regular car. Okay? We could distinguish between students and graduate students. A graduate student is a student. All right? Full-time faculty, adjunct faculty. Full-time faculty is a faculty member. Adjunct faculty are faculty members. So all of those are case of an is-a relationship. The thing to remember about an is-a relationship is that because an electric car is an example of a car, many of the things that we say about a car, we can also say about an electric car, right? I hope I don't betray my ignorance too much about electric cars, but, an automobile has 4 tires. So does an electric car, right? A hybrid has 4 tires. So does an electric car. I would imagine an electric car has a steering wheel. So does a regular car, and so on down the line. The idea is when you establish an is-a relationship, a specialization relationship, you sort of for free get all the attributes and methods on what's called the superclass. Now, I want to define some terms, subclass and superclass. It's pretty intuitive, but I do want to make sure that we have defined them. If I were going to say car, an electric car, on a class diagram, you typically show it like that, with an arrow pointing between electric car and car. And what that means is electric car is what's called the subclass, which means that it's a specialized version of the superclass. By superclass, we mean it's the more all-inclusive class, right? There are more cars than electric cars. So anything that's an electric car is also a car. But anything that's a car is not necessarily an electric car. So there could be hybrids, diesel, convertible, and so on. Now, that begs an interesting question, right? What do I do with an electric car that is a convertible? All right, I could have an electric car that's a convertible. All right, Java only allows for a single level of inheritance. The process of setting up a sub-superclass relationship is called inheritance. In other words, an electric car gets everything from an automobile for free and can expand or build upon it. But you can only do that to one superclass. I can't, for example, have, let's see, I can't do something like this. I can't say that an electric car is a subclass of both an automobile and battery-powered vehicles. I can't do both of those. I have to pick which one. Now, we'll talk about what to do when you have that situation. The bottom line is it would get very dicey in terms of what function overrules which function if you're allowed to inherit a couple different ways, if you had multiple inheritance like that. So the implementers of Java took the easy way out. You get rid of a lot of problems if you simply allow one level of inheritance or one level of specialization, subclass and superclass. We will talk about how you address that situation, though, when something fits two different categories. Because you're not without tools here. You just can't use inheritance to show that. How do you decide which to go on? Well, we'll talk a lot more about this later on when we talk about interfaces. And by interfaces, I don't mean like a GUI interface, but there's a kind of structure in Java called an interface. But generally speaking, you're best off if you take a sort of a real-world view and say, what does that more seem like to me? You know, which is the stronger is a relationship? For example, you know, if I was creating, just to think of something goofy, if I was creating a structure about things that fly, and I could have airplanes, helicopters, birds, and so on. I might also try to put birds in a has feathers or feathered subclass. But really, when I think of birds, probably the defining characteristic is that they fly. That they have feathers is sort of an incidental. All right? In other words, they probably have more things in common with other flying things than they have in common with things that have feathers, like a down jacket and a pillow and so on. Now, that's kind of a goofy example, but there are sort of levels to the strength of the is a relationship. And I'm sort of getting a little ahead of myself, so I'm going to sort of reel myself in now, and we'll leave this to when we talk about interfaces. But in general, if you have a choice, you look for what seems to be the strongest is a relationship, especially within the context of a problem domain. All right? So if I'm a battery manufacturer, maybe it makes sense to put electric cars under a battery-powered vehicles. But if I am an automobile manufacturer, maybe it makes more sense to consider electric cars as being an automobile. And anyhow, let's review again in more detail what happens when we have an is-a relationship. When we have an is-a relationship, the subclass gets all of the methods and properties of the superclass, And it can extend those by having additional properties and methods. For example, a electric car, has tires just like a regular automobile has. One thing that an electric car wouldn't have that a regular automobile would have would be how long it takes to charge its battery. What's the lifetime of the battery? Does it work for 100 miles or 500 miles or what? Another thing that might be different for an electric car versus a regular car is the manner in which it's refueled. So if there's a refuel method, maybe that method will be different for an electric car than it would be for there. So the subclass gets everything that the superclass has, but it can add more things and it can override or change some things that the superclass doesn't have. I do want to show you this as an example of, I really lucked out in looking for this example. I wanted a nice simple example of a class diagram. And I found this. If you just Google class diagram, you can find several examples of this. And really what this shows in a nutshell is the classes in this particular system and a relationship. The things I want to point out, number one, if there's just a line between them, that's what we would call a collaboration, where it's neither inheritance nor composition. Where there's that black diamond on the top, that's an example of composition. In other words, the catalog really consists of a bunch of books. The catalog of a library consists of a bunch of books. And then finally, where you see the arrow on the top is an example of subclasses or inheritance. In other words, they have, for books, they have reference books and they have issuable books. In other words, books that you can take out of the library. Likewise, for the member of the library, they have faculty and student. And notice they have a different method for checking them out. Right? When I go to the library and check out a book, I have it till the end of the semester. All right. I guess they figure that faculty members read slow, so they got to give them a lot of extra time to read a book. But if you were implementing a system like that, the method for a person to check out a book would be different for a faculty member versus a student that's checking out books. The main point I wanted to show you in this, again, is the three main different symbols. A line between them shows that they collaborate. The diamond, the black diamond on top, shows that there's composition, and that shows that there's inheritance. Really, the big things is make sure you got where there's inheritance and where there's not inheritance correct. All right, what I want to do for today is I want to extend the example that we did last time with the consultant and the project to talk about a different kind of consultant. All right? This would be, for lack of a better word, a specialist consultant. All right? In other words, we have ordinary run-of-the-mill consultants, but for some consultants are deemed to be specialists. All right? And what does that mean? Specialist means, again, that they have a specialty. They specialize in something specific. They're not just your ordinary run-of-the-mill consultant. And as you might imagine, they get paid more than a regular run-of-the-mill consultant. Let's say, for example, that they get paid 50% more than your average consultant. So, we had this before. We had this pay schedule last time. Whereas, A junior consultant gets paid $20. A regular consultant gets paid $30, and a senior consultant gets paid $40. Let's say that if you're a specialist consultant, you get paid 50% more than that. So a junior specialty consultant would get paid $30 an hour. A specialist regular consultant will get paid $45 an hour, and a specialist senior consultant gets paid $60 an hour. All right? Their billing rate, let's say, is calculated the same way. In other words, their billing rate is still 3 times their pay rate. It's just that they're paid on a different schedule. Okay? Now, in addition to that difference, the other difference is the specialist has a specialty. All right? Whereas the regular consultant is assumed not to be a specialist in any particular area. They're meant to be a generalist. So there's an extra attribute that the specialist has, that they have something called a specialty. So let's talk about what we have to do to implement this. All right? What we have to do is this. We have to create a class specialist, and I have to say that it inherits from my consultant class. All right? I thought I turned that off. We'll just leave it. The way that you say you inherit it is by saying that it extends. So class specialist extends consultant. What that means is if we were drawing the class diagram, we would have consultant and specialist. And put in the is-a terminology, a specialist is a consultant. They're a special kind of consultant. All right? Now, the reverse isn't true. A consultant is not necessarily a specialist. So this is a superclass. This is a more inclusive class. This is a subclass. This is a less inclusive class. Now, the only differences between a consultant and a specialist is that a specialist has a specialty. All right? A specialist has their pay rate calculated in a different manner. All right? So, let's go in and I'm going to go and I'm going to put an attribute string specialty, and I'm going to create my get and set methods. Better make this guy private, all right? Now, I'm going to go in and I'm going to do something not necessarily the final way I'm going to do this. I'm going to change this. But for now, I'm going to go and do it this way. And I'm going to say, I'm going to create the get pay rate as 50% more than the consultant's regular pay rate. All right? And that's all I need to do. All right? That's sort of all I need to do. All right? The one thing that we haven't talked about, the one thing that's a little bit different when you have inheritance is constructors. Constructors don't inherit. Okay? So the fact that consultant has a couple of constructors, I am going to go and I'm just going to copy those into my specialist class. All right. Now, a couple things about this. We could do better, and we will do better. All right, but this is enough for now. All right. So I think everything is correct. There's probably a 14-year-old kid watching this on YouTube right now. All right, not right now, but when it gets posted. That's probably spotted a syntax error I made, and they're probably already writing the comment to say, "You idiot, you forgot a semicolon," or something like that. I hope not. All righty. Where do I want to put this? I want to put this in C, Java, and I want to call it specialist.java. All right. Now, I could jump in and start testing this with the code that I was using last week to test the consultant and the project and all that, but I don't think that's a good idea. All right, because that's sort of jumping ahead to the system testing, the integration testing of all these classes. I want to write some little straightforward test routines just for this specialist class. So let's go, and if I remember right, test Java was pretty, yeah. Let's go and save this as something like test 4 Java. And let's go and let's create a specialist. Specialist equals C equals new specialist Mike. All right. Test case 1. I'm going to output, get the name, get the type, get the pay rate, and get the bill rate. I will go and change this. And I'll go and do this, and we'll see if it works. All right, so let's go and compile this. Question? Oh, for the third one? Yeah, thank you. Right. Should we save this? And let's go to the command line. All right, let's compile test 4. Hopefully have no stupid syntax errors. Cannot find symbol. Constructor. consultant. Okay. I'm going to go put a few lines. Yeah, I forgot about that. I'm going to go put a few lines of code in here. Or actually, the quickest way for me to do this is I'm going to give, and I'm not going to really talk about why I'm doing this now. I'm just going to fix the error. I'm going to give a no argument constructor for consultant. We'll come back to that later. I forgot about that. All right. All right, we're good to go. We'll come back later to why I had to add a no argument constructor. The way that constructors work with inheritance is, I won't say it's hard or complicated, but it's something you got to remember, and it works a certain way, and you got to remember. All right, so now let's go and run this. Java test 4. And it says Mike's a regular consultant, and their pay is $45, which is correct if I remember right. And the billing rate is 3 times that, or $135. Mike is a senior consultant, gets paid $60 per hour. That I also think that's correct, and is billed at $180 per hour. Mike is a junior consultant, his pay is $30, and bill is $90. Now, so that looks like it worked to me. All right. Now let's again review what we did here. I didn't have to redeclare the attributes. I only had to declare the extra attribute. In this case, even though I didn't really test it, we can sort of take our word that this one would work. I declared a extra attribute for specialty. All right, so I didn't have to go in and declare consultant type or name because those were declared on the consultant class. So because this extends that, you get everything that's in this class plus the additional things that you declare. Likewise, I didn't have to declare set name, set type, get name, get type, or get bill rate. Why? Because for a specialist, all those are the same. Set name, you give it an argument, it sets the name. Set type, you give it an argument, you set the type. Likewise with the gets for those. Likewise with calculating the billing rate. The billing rate we still said is 3 times the pay rate. Now, what method did we declare? We declared the methods that are not in the consultant class. So for example, that are not in the consultant class or are different from the consultant class. For example, there is no set specialty or get specialty in the consultant class because consultants don't have that attribute. All right, so there is no get and set. Likewise, the get pay rate method is overridden in this class. Why is it overridden? Because it's different for special consultants than it is for regular consultants. In a nutshell, essentially what we've done is we've really coded the differences between the consultant and the specialist. All right? Plus we threw in some constructors. Constructors, again, are sort of their own topic that we probably won't get to tonight, but we'll get to at some point. So what we've coded is the differences. We added the extra attribute that doesn't exist on the consultant level. We added the extra methods to set and get, and we changed the one method. We overrode the method for calculating pay rate because the pay rate for a specialist is calculated in a different manner than the pay rate for a regular consultant. Yes?
Is there a way you
Yes.
the exact same signature
Uh-huh.
as the method?
Right.
So is there a way to tell the method in your subclass that
Is there a way for what to tell?
How would you, if you're looking at get pay rate, how would I know? If I didn't know it was in class, how would I know that method?
You wouldn't know just by looking at the code. Yeah, there's really no way of saying that. In other words, get pay rate could be a brand new function in Specialist.
Right.
Now, we know that it's not. All right, we know that Consultant has one. I guess the way you could tell is if you did Java documentation, you could say it does it, or you can always put a comment in. Like that, to identify if that, you know. But yeah, otherwise, just looking at the code without comments or additional documentation, no, you couldn't tell. Yes?
In a situation like this where you really have a value of 1.5 times,
Mm-hmm.
when does it become a better choice to write a new method to calculate based on that?
Excellent question. As they say, there's there's more than one way to skin a cat. We could possibly implement this a couple different ways. The reason that it's better to keep the same method is due to something that we're going to talk about probably in a minute here, called polymorphism. All right, polymorphism, if you play words with friends, that's a great word to keep in the back of your head. All right. It comes from the two words, I assume Greek or Latin, or probably Greek. Poly meaning many, forms, morph meaning forms. So polymorphism means that many forms can be taken. So this will become apparent when we go into the project class and make it so that we can assign either consultants or specialists to the project. When we do that, we'll see polymorphism at work, and we'll see really the benefit of keeping that the same method name as opposed to calculating specialists' pay rate or something like that. That's where we'll really see the benefit of doing that. Now, what I thought you were going to ask is, gee, if it's really literally 50% more, it's a shame that we had to repeat ourselves here, because that code is just about the same. The only difference is that, the numbers we're assigning here are 1.5 times. What we can do is we can do this. We can actually call the function on the superclass. All right? So this makes for a lot more concise code. In other words, hey, give me what the regular consultant rate is and multiply it by 1.5. That's actually what I thought you were going to ask. Yeah, and that might be part of what you were asking too. But again, we'll also get into the polymorphism bit. Let's make sure this still works. And sure enough, it does. All right. Now, into polymorphism. And we have about 10 minutes. This, how do I want to say this? I don't want to bias you about this. But this is a tricky topic. So we'll talk about it. We have about 10 minutes to introduce it today. But believe me, we'll come back to this one over and over and over again. Polymorphism means that we can treat, how do I want to put this? We can treat an object several different ways, and it will always work out and will call the appropriate function. Now, that's not really a very good explanation. Yeah, you know, if I had any sense, I would edit that out. But let me show you what I mean. This might be an easier case to show as opposed to tell. Let's open up this project class. No, let's open up our test class. Let's make a test 5 class. All right. Test 3 was where we had the array list of consultants on a project. Let's save this guy as test 5. Now, watch this. Nothing up my sleeve, as they say. I'm going to make Jeremy a specialist. All right? Now, I'm not going to say consultant E. Well, I will. I will say that. I will say specialist E equals new specialist Jeremy. Okay? I'm then going to go and let me go and clean some of this out. Jeremy the specialist. All right, let me make sure I'm doing this right. I'm going to call the constructor on project that accepts a consultant, and then I'm going to go and calculate that and see if the charge is right. All right, let's make sure that this works. All right, it said that the expense for this is $4,500. Let's make sure that that's correct. What is the expense? The expense is going to be simply his wage rate. So there's 100 hours. Does Jeremy get paid? Well, Jeremy is a regular specialist, so he gets paid $45 an hour. So sure enough, that's true. Now, here's a question for you. All right. Let's look at this constructor. And let's go and look at it in the project. Where's my constructor that accepts a specialist? I don't have one. But it worked. How did it work? Yeah, go ahead. Yeah, because a specialist is, after all, a consultant, right? So therefore, I can go and I can use a specialist where a consultant is needed. So let's think again of like your homework assignments where you have an automobile, let's say. If I created a class for hybrid automobile, if you're going on a trip and you say, I need an automobile, would it be acceptable if someone gave you a hybrid? Sure, because a hybrid can do everything that a regular automobile can, and it can do some other things as well. Now, here's where we get into polymorphism, though. All right, and here's where it's important to understand the whole business of the stack or not the stack, but the heap and object pointers and overriding functions and all that. Now, notice that our method to calculate expense creates a consultant object, grabs that consultant object off of the array list, and casts it as a consultant, and calls the get pay rate method, yet the method that we got is not the method that existed on the consultant class, but the method that existed on the specialist class. All right? That is what polymorphism is. So even though I'm saying call calc pay rate, and I'm saying I'm calling it on a constructor object, not constructor object, consultant object, that consultant object is actually pointing to a specialist. All right? And therefore, it will use the proper method. It will use the get pay rate method defined on the specialist. So, in other words, when we go and we create on the heap an object, my test code created a specialist called Jeremy. All right? It created a specialist object here. And a specialist is a consultant, so I can treat this object, depending on how I want to, as a specialist, or I can treat it as a consultant. But when I call a method on it, there's only one object on the heap with one get pay rate method. And it'll get the right method for the kind of object it is. All right? It'll get the method for the kind of object it is. So getting to your question before, I would want to call that the same thing so I could treat this polymorphically. So I could have my project method look through all the consultants, call the get pay rate method, and if that happens to be just a plain old consultant, it will get the plain old consultant's pay rate method. If it's a specialist consultant, it will get the specialist consultant's method. Now, we actually can go even a little different than that. I can actually say in here, consultant E equals new specialist. All right? Can it do that? You bet. Why? Because a specialist is a consultant. All right? And it will still use the proper method associated with the specialist when it calculates the pay rate. Yes?
So if you go on from here down the road, try to say consultant.
Okay. Okay. Let's make sure this works first. Then we'll go in and we'll answer your question. Okay, so that still works. So, for example, what you're saying is something like, I want to go on my test code. Maybe something like this. Let's do this. Let's say D equals E. Like that you're asking about? Well, let's think of what's going on here. This creates a new consultant object on a heap. This creates another new consultant object on a heap. This creates a new specialist object on a heap, and I'm pointing to it with a consultant object. I then say, assign the pointer for that specialist consultant to this variable. Should work fine. Just because this used to point to a consultant, it can still point to a specialist because, again, after all, a consultant is a specialist. All right? Correct. A specialist is a consultant. Have me thinking that. Right. This consultant can point to this object because a specialist is a consultant. So it can point to it. All right? Yes?
Is it proper then to say consultant E specialist?
Mm-hmm.
Is it then not proper then to say?
That is correct. In other words, the question was, could I do this? Could I say, specialist F equals new consultant? And the answer is no, I can't. Because not all consultants are specialists. All right? All specialists are consultants. So I can put a specialist object in a consultant object reference pointer, but I can't do the reverse because a consultant is not necessarily a specialist. There's a lot more things that we could do. Let's make sure this works. I'm not sure I actually tested this. And it does. We'll definitely talk more about this next time. You folks are probably like, I wish it'd wrap up already, but I could really go probably for another hour talking about this because there's a lot of interesting implications. Like, for example, let's just explore one of them. Since I declared this as a consultant, I can't do that because it isn't aware of the set specialty method on a consultant, because there's no such thing as a set specialty method on a consultant. There only is on a specialist. All right? So in a nutshell, I can call the methods that are defined, I can only call the methods that are defined on consultant. But if I call one of those methods, I'll get the proper version given the fact that this is a specialty class. All right?
So generally, you wouldn't want to do it.
It would really depend on what I'm doing. So, for example, for the purpose of this, if I'm like calculating the revenue and calculating the expenses, I want to treat everyone like they're a consultant. I want to get their, I'm not interested in their specialties. I want to get their, I want to get their wage rate and show show how much I have to pay out and show how much I'm going to earn from them. So in that case, or put differently, if I look here, again in the project, or remove consultant or whatever, I want that to work. I want all the functions inside project that address a consultant to work whether it's a consultant or a specialist. Therefore, I'm going to declare any of those variables as consultants. So in that case, yeah, because I want to treat them like they're consultants in that case. If there was an instance where I wanted to treat them as a specialist, I would then declare it as a specialist. All right. We'll go over this again in a lot more detail next time, and we'll explore this, and we'll also discuss probably, I have to check my notes, but we'll probably hit the way that constructors work. Right? Because constructors are sort of the wild card here. They don't necessarily follow the rules of inheritance. All right. We'll see you over in lab.